Hi everybody, sorry for that abrupt ending to our last video. I got cut off because I didn't have enough room on the iPads, so I started a new recording here. I believe we left off here, so pause the video, try out this learning check, and then check back in. So you want the atomic number, the number of protons, and the number of electrons for each of these elements. All right, so the first step that I like to do is I like to locate my element on the periodic table. And that's going to help me find out the atomic number. So for the first one, nitrogen, that's got an atomic number 7. So how many protons does it have? I mean, you can see it right there. But because the number of protons is equal to the atomic number, once you locate the element on the periodic table, you have the number of protons. So yeah, there's 7 protons. And then remember, it's a neutral element. I haven't been told that it's not neutral. So, and in the future you will be told if it's not neutral, okay, if it has a charge. So the number of protons with a positive charge has to equal the number of electrons with a negative charge. So we have 7 electrons as well. Okay, zinc has an atomic number 30, so it has 30 protons and 30 electrons because we have 30 positive charges and we need 30 negative charges to counteract that. Same thing with sulfur. We got 16, 16, and 16. Won't always be this easy, but this type of chart is something you might want to practice because we'll do a lot of that in your homework and in the future. Okay, so another thing that we use to describe our atoms is the mass number. So the mass number represents the number of particles that are in the nucleus. And remember, the particles that are in the nucleus are the ones that are contributing to the mass of the atom. Because protons and neutrons, right, the particles in the nucleus, those actually are so much more massive than the electron that we just ignore the electron's mass. Okay, so it doesn't contribute to the mass, so it's not part of this mass number. Okay, so the mass number is equal to the number of protons plus the number of neutrons. Okay, it's always a whole number, and the mass of a single atom does not appear in the periodic table. You will see another number under your symbols on the periodic table, and we'll talk about what that number is in the future. It's called the average atomic mass. That's different. The mass number is the number of protons and number of neutrons added together. The average atomic mass is something different. All right, and here's just another table. We're not gonna go over it too much, but it's there for you if you're interested in looking at some of the other, seeing if you can find any patterns in here, making more sense of these different numbers and stuff. Okay, so this is just reiterating some of the stuff we said. Number of protons equals the atomic number. The number of protons plus neutrons equals the mass number. And then the number of neutrons equals the mass number minus the atomic number. You don't necessarily have to remember this equation, because if you remember this one, you can rearrange the equation to get the number of neutrons. So say you were given the number of protons here and you knew the mass number, you could solve for the number of neutrons. Okay, so you don't really have to remember that third one, but you can if you would like. All right, so try this out on your own and then let's come back and check it out. All right, so an atom of lead has a mass number of 207. I actually just want to do it up here. So the mass number is 207, okay? And then we have lead. So how many protons are in the nucleus? How are we going to find out that? Yeah, we got to look for the atomic number. So what's the atomic number of lead? Yeah, it's 82. You might have had to do a little bit of scouring, and that's okay. You'll get more used to the periodic table as you use it. So 82 protons. Okay, if the mass number is 207 and we have 82 protons, can we find the number of neutrons? Yeah, we can take the mass number, which equals the number of protons. I'm just going to represent it like that, plus the number of neutrons. And we can kind of do some algebra. So 207 equals 82 plus x. So 207 minus 82, I did the math already and I got 125. And that equals our x, which is our number of neutrons. So 125 neutrons. All right, and then how many electrons? Well, we said unless you're told otherwise, it's a neutral atom. So that atom must have how many electrons? 82, yeah. Because electrons are negative, whoa, that was supposed to be a negative sign, and protons are positive, okay? Check our work here, looks good. All right, let's move on to 4.5, which is about isotopes and atomic mass. I'll try to get to 7.1 if we can here, but we'll see. All right, so isotopes and atomic mass. So here's another way that you'll see atomic symbols written. So in this case, magnesium, which one of these numbers is the atomic number? Sorry. Yeah, it's actually 12. So if you look at the periodic table, 12 is the number on top. And we said that that's the atomic number. Okay, so that's the number of protons and the atomic number. So what's this number on the top, do you think? This is the mass number. Okay, so the mass number is, remember, number of protons plus number of neutrons. So just off the top of your head here, try to see if you can figure out how many neutrons does this magnesium atom have. Yeah, it has 12. Okay, so isotopes. So isotopes are atoms of the same element that have different mass numbers. And then I think a better way of saying that is different number of neutrons. Because yes, they have different mass numbers, but the reason that the mass number is different is because we have a different number of neutrons. So it's a little bit more specific to think of it that way. So they're the same element, and they have the same number of protons, right? That's what makes the element, right? Remember, that's the fingerprint of the element is the atomic number. So number of protons, P plus. But they have different number of neutrons, and they can be distinguished by their atomic symbols. So you'll see maybe something, just for an example, is maybe you'll see this 25 on top. And how many neutrons does that have? Well, up here, if the mass number is the number of protons plus the number of neutrons, we must have 12 neutrons in this example. Whoops. 12 neutrons. But in this one, how many do we have? Remember, the number of protons doesn't change. Yeah, we would have 13 neutrons. And the reason that mass number is higher is not just because of that mathematical equation we have, it's also because if you have an extra neutron, you're adding to the mass of that atom because you're adding something that has mass. Yeah, if you add electrons, it's not really affecting the mass a whole lot. But if you add a neutron, it does. Okay, sorry, just rambling a little bit here. Okay, so atomic symbols. Subatomic particles. So given the atomic symbols, determine the number of protons, neutrons, and electrons. So we want to know, given these atomic symbols here, just like we had up here, how many protons, how many neutrons, and how many electrons do we have? Okay, pause the video, try it out. Okay, so they made a nice little chart here for us. So the first thing that I always start with is I start with the atomic number. I know that even if I have an isotope of my atom, which what does that mean? That means it's the same number of protons, it's the same type of atom, but it has a different number of neutrons. So even if I have an isotope, I know that the atomic number is not changing, right? That number on the bottom is not going to change. If you have 8 there, you have oxygen. If you have 15, you have phosphorus. If you have 30, you have zinc. Okay, so start there. That's what I would recommend. So we got our atomic number from the bottom numbers, so 8, 15, and 30. Actually, let's look at them one at a time, sorry. So we'll look at the first one. So our atomic number is 8. So we can also fill in this column, right? If we know our atomic number, we know our number of protons. And you'll notice these columns are the same, and that's because they're not changing. We're not changing the number of protons when we have isotopes. Okay, so, all right, so now let's look at the mass number. So our mass number is given to us where? Yeah, on the top here. So our mass number is 16. So how many neutrons do we have if our mass number is 16 and our number of protons is 8? Yeah, we have 8 because mass number equals number protons plus number neutrons. Sorry, that's an N. Okay, so if our mass number is 16, then we have 8 plus what equals 16? Oh, 8. Yeah, so we have 8 neutrons. All right, try the next one. So the next one is phosphorus, which has atomic number 15, which means we have 15 protons. Okay, our mass number is given to us here, so that's 31. So what's our number of neutrons? Well, 31 minus 15 is going to give us 16. Okay. All right, and then how about zinc? Zinc, we have a mass number of 65. Our atomic number's on the bottom there, 30. So 65 minus 30 is going to give us the number of neutrons, and that's 35. Okay, so for an example, we're finally going to talk about that number on the bottom in the periodic table. So magnesium has 3 naturally occurring isotopes. And what that means is that what isotopes really are atoms of the same element that we have different number of neutrons. And we find that there are certain elements that have, say, 3 different types of isotopes, like magnesium, or we have some elements that have 2 different types of isotopes. Carbon has a few different types of isotopes, and that what we end up doing to get this number on the bottom is we're averaging the mass numbers of each of those, or I'm sorry, we're averaging the percent abundance of each of those isotopes to get an average atomic mass, which is reported in AMU, so atomic mass units. So we have, here's a table that breaks it down even more. So we have the name of the isotope. And something that's interesting is you'll notice here, so notice that our mass number is given to us up here. So we have magnesium with a mass number of 24, 25, and 26. So what we do is we name those isotopes using this naming system, where we tell you what type of atom it is, right? It's magnesium. And then we put the mass number, we put a little dash and then the mass number next to it. And that's telling you what type of isotope we have. And the way that you say this out loud is you say magnesium 24, or magnesium 25, or magnesium 26. Okay? You might have even heard like carbon 12 or carbon 13. And that's because carbon forms isotopes as well. We find isotopes of carbon in nature. Okay, so again, the number of protons is staying the same, right? That's 12 all across the board. It's a neutral atom, so the number of electrons are the same as the number of protons, right? I haven't told you that it's not neutral. But the mass numbers are different, right? And that's because we have a different number of neutrons. And I know that because we're talking about isotopes. Same number of protons, different number of neutrons. Okay, so our mass number is going to be the same as these numbers here. Okay, so those are our mass numbers. And then it even shows you the number of neutrons. So if you have 24 as your mass number, minus 12 protons is going to give you 12 neutrons. 25 minus 12 is going to give you 13, and 26 minus 12 is going to give you 14. Okay? And then it gives you the mass of the isotope. So the mass of the isotope is reported in AMUs, and here we have 23.99 for the mass, right? Really close to 24, the mass number. Here we have 24.99, really close to 25, which is the mass number. And then here we have 25.98, which is really close to 26, which is the mass number for that isotope. And then we have this thing called percent abundance. And what percent abundance is it's telling you how much of the isotope, that isotope of magnesium exists in nature. So when we have magnesium, we have 78.70% of it as this form or this isotope of magnesium. So it's a more common isotope of magnesium. We also have 10.13% of this isotope of magnesium in nature. And then 11.17 of the magnesium on Earth is magnesium 26. Okay? So what that the atomic mass at the bottom of your each element on the periodic table is telling you is it's telling you the average mass, taking into consideration the mass of the isotope and the percent abundance. All right, so here's our learning check. So naturally occurring carbon consists of 3 isotopes, carbon 12, carbon 13, and carbon 14. So notice you'll sometimes see isotopes written like this as well. So you would see C12 as well, C13. You also sometimes actually just see it written out like this. That's really common as well. Any of these are representing an isotope with a mass number, an isotope of carbon with a mass number of 12. Okay? All right. So state the number of protons, neutrons, and electrons in each of these 3 isotopes. Pause the video, try it out. All right. We're not shown the number, the atomic number, but that's okay. We can go to carbon on the periodic table, and we're going to look at that top number, and that's the atomic number. So I'm just going to go ahead and write that 6 in here. That's my atomic number, so that's how many protons I have, so 6. I have a mass number of 12, right? So 12 minus 6 is going to give me 6, and that's where that number is coming from. And then it's a neutral atom, so we have the same number of protons as we do electrons, so 6. Okay, what about this next one? How do we do this? So again, first I locate the atomic number. So carbon, I know I have carbon as my element, so I know my atomic number must be 6. So I have 6 protons. I also know I have 6 electrons because I haven't been told that I have a that my element or my atom is not neutral. Okay, and then my mass number now is 13. So now I have to do 13 minus 6, which is going to give me 7 for my neutrons. All right, and then 14. 14 minus 6 is 8, so I have 8 neutrons here. And that makes sense, right? I'm getting more and more massive as I add neutrons, and neutrons are contributing to the mass of that atom, right? Okay. One more learning check. Well, there might be a few more, but in a little while. Okay, so write the atomic symbols for the atoms with the following subatomic particles. So now you're not even given the symbol. You're just given the particles. Okay, so this number here, this number here, these numbers are going to give you the atomic number. So that's what's going to give you the Sorry, my cat. That's what's going to give you the atomic or the identity of the atom that you have. So if we have 8 protons, our atomic number is 8, and we have oxygen. So that's how you fill in that O there. Now, it's telling us that we have 8 neutrons. So we know mass number equals number of protons plus the number of neutrons. So now we know we have to add these two up. 8 plus 8, that equals 16, and that's where that's coming from there. We're not representing the number of electrons on here, actually. So we don't really need to put that anywhere, but it's nice to know, I guess. In the future, you will have some differing numbers of electrons and some charges. All right, so for B, 17 protons, that means my atomic number is 17, so I have chlorine. My mass number is going to be the number of protons plus the number of neutrons, so that's going to give me 37. And then again, we got our atomic number. Our mass number is going to be 60 plus 47, which is going to give us 107. Okay. So hopefully that's starting to kind of make a little more sense here. Okay, so you can calculate the atomic mass, which is listed at on the bottom of your each element in your periodic table. So it's actually a weighted average of all the naturally occurring isotopes of that element. And it's the number on the periodic table shown below the chemical symbol. So chlorine with 2 naturally occurring isotopes has an atomic mass of 35.45 AMU. You'll also sometimes hear it referred to as the average atomic mass. It's the same thing. Okay, so to calculate the atomic mass, you're going to use the experimental percent abundance of each isotope of the element, and you're going to multiply that percent abundance by the atomic mass of that isotope, and then sum all of those masses. So let's break this down a little bit. So now we're calculating the atomic mass of chlorine using experimental data that we got for both isotopes. So here's the atomic symbol of each of those isotopes. We have one is chlorine 35, and the other one is chlorine 37. So what we're going to do is we're going to take the mass AMU of each of those isotopes. So notice that this mass here is pretty close to 35, right? And this mass here is close to 37. So that's that checks out with our mass numbers there. And then we're going to multiply by the percent abundance of that isotope in nature. Okay, so how much of our chlorine that we have exists as chlorine 35 and how much exists as chlorine 37. So we're told that the percent abundance, you wouldn't be expected to come up with this. We're told that the percent abundance is 75.76 out of 100, so 75 or 76-ish%. And then for chlorine 37, it's 24.24%. Okay, whoops. So we're taking the mass of chlorine 35 in this up here, mass chlorine 35, and we're multiplying it by our percent abundance. And then we're adding that number, so you could put some parentheses around that, to the mass of chlorine 37 times the percent abundance of chlorine 37. Okay? And then you're going to get the contribution to the atomic mass. And then once you actually add those numbers, you'll get the weighted average mass. Looks really complicated, but you get used to it. So the atomic mass of some samples is listed here. And remember, what they're doing to get these numbers is they're doing this. They're saying, okay, what isotopes do we have of this atom? And how abundant are they in nature? Okay, and then we can figure out, okay, well, what's the weighted average mass of these isotopes? Okay, and now you can see on the right-hand column, you can see what the most abundant isotope, they've actually broken it down for you. So lithium-7 is more abundant than lithium-6. Carbon-12 is the most abundant. Oxygen-16 is the most abundant. Fluorine-19. Sulfur-32. Potassium-39. Copper-63. And what you'll notice is that the atomic mass, the weighted average, is going to be closer to the most abundant isotope. So here, the atomic mass is, the weighted average is 12 AMU-ish, and our most abundant isotope is carbon-12, right? So we're not seeing 14 AMU because most of the carbon that we have is carbon-12. Okay, same thing with oxygen. Most of the oxygen that we have in our atmosphere is oxygen 16 rather than oxygen 18, right? So we don't have an 18 here, we have 16. So our mass is closest to the most abundant isotope, the mass number of the most abundant isotope. All right, so let's do a quick learning check. So gallium is an element found in lasers used in compact disc players, CD players. In a sample of gallium, there's 60.10% of gallium-69, which has an atomic mass that they're giving you, atoms. Okay, so about 60% of the gallium we have is gallium-69, the isotope gallium-69. The other 39.9% is gallium-71 with an atomic mass of 70.925. So what's the atomic mass of gallium? And remember, that's calculating the weighted average. Okay. Okay, so let's just go through. I think it'll be easier for me to just do this up here. I guess we could just look at it. Okay. So we'll just break it down together. I was just going to go through it with you, but instead of having you pause it, but we'll just go through it together here. So what we're going to do, remember, is we're going to take the mass, right? And we were given that. We were given that up here, right? The atomic mass here, okay, of those specific isotopes. And then we're going to multiply it by each isotope's percent abundance. So here's the atomic mass of that isotope, and then I have the percent abundance. And remember, when you do percentages, you're going to have 60.10 over 100. Remember that anytime you're writing a percentage, you can think of it as if you have 60% of something, you're going to write that as 60 per cent or per 100. Think of like a century. 60 per 100. So 60 something out of 100 something gives you 60%. Or in this case, about 60 out of 100 atoms of gallium are gallium-69 isotope. Okay, so you can always write your percentages like that. All right, so what we're doing, and I like to see the parentheses, is we're taking the mass and we're multiplying that, the mass of gallium-69, and we're multiplying that by the percent abundance of gallium-69, and we're getting 4142 AMU. Okay? And you can try that calculation out yourself and see how that works. Then right here, we're going to take the, mass of gallium-71, and we're going to multiply it by the percent abundance of gallium-71, and we're going to get this number here. Okay, are we done? No, right now that's just the masses of each of those isotopes, or the atomic masses of each of those isotopes. We want to do the weighted average. So how are we going to do that? We're going to add the contribution of each isotope, and that's going to give us the atomic mass. Okay, so 41.42 plus 28.30, those two numbers here, gives us 69.72. All right, so